Hello again and welcome. Page 207 in your book is where we are still working, and we're now going to talk about something similar to the last lesson. And I'm going to tell you right up front, this is a little tricky one, and it's going to require you probably to review the video, pause, watch the video to understand it. Your life will be much easier if you do it that way. Please pause it, re-listen when things don't make sense. With a little bit of practice, it will click, and hopefully you'll be able to go on and solve these questions that just take a little practice. All right. If you have not yet filled out your template, please do. Here's the topic and objective for today: absolute value inequalities. Still in chapter 3.7. It's going to take a few videos for me to do this, at least 2, if not more, depending on how long they take here. So start by putting this question. The main idea here for this first part is, how do you solve a graph with a less than or less than equal to sign with absolute value such as this? Get that down, hit pause if you need more time, and then let's just recopy that question in here. Now what you need to do is you need to really think of what would be a possible answer. Okay, so over here in the description area, what you're doing here is you're trying to give yourself things that are going through your head. So consider, this is what you should think. Consider what value of x is true. Now I think what would work really well is if we picked a number line, and let's just, since we know this x is here and we're going to take the absolute value and it starts at 5, let's just stick 5 on here, and then consider what value of x would be true. Okay, well, first of all, would this be true? I'll use red here. Is x equal 5 a solution? Well, is this a true statement? The absolute value of 5 is less than 5. Well, I think the absolute value of 5 is 5, and 5 is not less than 5, so no, that is not. So 5 is not a solution, so let's try another number. How about 4? All right, let's try 4. Is x equal 4? And let's try that. Absolute value of 4, is that less than 5? Well, the absolute value of 4 is 4. 4 is less than 5. That is true. I'll do a smiley face. So that means here at 4, I have a solution. I have a point there. What about 4.5? Would that be true? Well, yeah, 4.5, so I'd have a solution here. How about 4.6? So I could go all the way up to 5, but don't include 5, so does that look familiar? I'm going to put that boundary there at 5, and notice I have number on this side. That was 4. How about 3? Would 3 be a solution? 3 is less than 5. Yes, 3 would be a solution. 2, 1, how about 0? Is 0 a solution? Yeah. So we have all of these. Let's go over onto the negative side. I'll continue here. How about negative 4? All right. Is that less than 5? Okay. 4. Right? The absolute value of negative 4 is 4. 4 is less than 5. 0, negative 1, negative 2, negative 3, negative 4. All right, how about negative 5 then? Well, the absolute value of negative 5 is 5, so that's not a solution because 5 is not less than 5. 5 equals 5. How about negative 6 over here? No, 6 is not less than 5 after you take its absolute value. So notice what we have here. We have this graph that looks a lot like what we did when we were graphing inequalities. Notice that that looks like an AND inequality, and it is. Okay, so anytime you have less than, or if you have less than equal to, you will end up with an AND. And what we could say here is we could say the actual solution, typically what you're going to have to do is two things. One is to make that graph, and the other thing is to describe the solution just like we did when we did inequalities. You would say negative 5 is less than x, because this represents all the values of x, and negative 5 is less than x, okay, because x is up here, so negative 5 is less than x, and x is less than 5. So that's really your solution there, all right, and that is your graph, okay? And let's look back at what the question said. It said, how do you solve and graph with a less than or less than equal to sign? So it works out like that. A less than or less than equal to sign will always work out to be an equality there, okay? So that is a very basic example. This concept is a little bit confusing and weird, so it's a really simple one. Let's take a look at what one that's not quite so simple, but it's in the same vein based on what we learned. All right, copy this down. Solve and graph solutions for this inequality. The absolute value of 2v minus 1 is less than or equal to 9. This is actually out of your book on page 211. Number 43, so it's going to be really similar to the homework you're going to see in class in the next class period. All right, now before I do anything, the first thing I'm going to identify here is that less than or equal to creates an and. Now that might make my life a little bit easier. Okay, so let's try it. Let's copy it down. Let me go back to my other color here. The absolute value of 2v minus 1 is less than or equal to 9. All right, so basically here's what you're looking for. You are looking for values in here that are less than or equal to 9. So in other words, because of what we learned from this right here, all right, this at the top of your notes, you should have, you should put a dotted line after the first half there. All right, I know that it's going to be a barrier where negative 5, or the negative value, is the left barrier and the 5 is the right barrier. So I can take this and I can divide it into two inequalities that make an and, like this. The left barrier is negative 9, the right barrier is 9. All right, that's less than or equal to. That's less than or equal to, and what's in the middle? This is in the middle, 2v minus 1. So negative 9 is less than or equal to 2v minus 1 is less than or equal to 9. So now I'm going to just solve this problem. I'm going to add 1. Remember how we did this in class? Add 1 to each side. We're just doing 3 at a time, just keep it balanced. Negative 9 plus 1 is negative 8. That's less than or equal to, that's just 2v now. And that's less than or equal to 9 plus 1 is 10. So you have this, and solve that for v. That's 2. Okay, negative 8 divided by 2, that's negative 4. Less than or equal to, that's v. That's less than or equal to 5. Now, what you've done, if you've isolated the v, and that's what you're trying to do. You're trying to get that v isolated. It just happens to be an and inequality. And so you have the left barrier is negative 4, and the right barrier is 5. The question did ask, if you copied it down, it said solve and graph. On your left you have negative 4, and then you got your 0, and then over here you've got 5. Now since those are less than or equal to, I'm going to put a solid dot in there, and you're going to fill it. And that is the solution. This whole thing is the solution here. All right, that is the solution. One written as an inequality and one written with a number line to show the infinite number of possibilities in those decimal values. And that's how you do with a less than or a less than equal to sign. If you wanted to, you probably should pick one of these values, because these are the values of v. Put it in here and see if it's true. Like, let's just do 0. All right, according to this, 0 would be a solution. So if I put 0 in there, I would get negative 1. Absolute value is less than or equal to 9. The absolute value of negative 1 is 1. 1 is less than 9. How about 2? So I picked a value here. 2. 2 times 2 is 4. 4 minus 1 is 3. 3 is less than or equal to 9. That's true. So that is the set of solutions there for you. Now there's another part to this where I talk about what if we have a greater than or greater than equal to sign, and something a little bit different happens there, and we will talk about that in the next video.